team networking. In this video, I am going to talk about subnetting for IPv4. And I'm going to use this example that I'm showing you right now on the screen, which is I got an IP address. I need to subnet that IP address, and I will have three cases. So I'm going to have each case individually and see what can be done there. Now, before I get starting in the how do I subnet, let's just go back and try to understand what is the point and why do we need to do subnetting. Now, the idea here is when you have a network, a big network, and let's imagine here you have 1,000 computers inside that network. The thing is, each one of those computers is going to constantly produce broadcast messages. And imagine that you got 1,000 devices, so 1,000 devices are going to be producing those broadcast messages. And every single device in that network is going to be basically receiving 999 of those broadcast messages every once in a while. And because of that, we will end up consuming the bandwidth of the network with all these broadcast messages, and we are going to be wasting the resources of every single one of the devices that we have in this network processing those broadcast messages, because again, any device in that network will receive that broadcast message, is going to have to decapsulate it, extract the information to realize, oh, this has nothing to do with me, so I'm just going to drop it. That process takes time and take power of your machine. So you're ending up losing a lot of the bandwidth and losing a lot of the time and the power of your machines. And for that reason, what we like to do, instead of having all our devices configured under one network, what we can do is we can divide our network into smaller networks. And the idea here is very simple. You can imagine that if my entire network, let's say this is my whole network, I can break down my network into multiple networks. Let's say, for example, 3. So there's going to be network 1, there's going to be network 2, and this will be network 3. Now, previously, if I was treating all these networks as one network, I will have one router here to get me connected to the internet, and all these networks probably will be connected using a switch, and then that switch is going to be connected to the router. So any broadcast message that's going to be passed from any of the devices in this network will basically have to go to all the other devices. Now, the idea here, instead of doing it that way, I can replace the switch here with an actual router. So this is going to be the router that's going to connect me, for example, to the internet. This is an internal router. And the job of the router, basically, every time a router receives a broadcast message from a network, is going to drop it, and it's not going to pass it to the other networks. So if a broadcast message was generated inside network 1, only devices in network 1 will receive that broadcast message, which basically will simplify will make the process or make the performance of the system a lot better. So these devices, for example, will not receive any broadcast message from this network, and those devices will not receive any broadcast message from this network. So each network will have its own broadcast messages. Now, of course, this will come with a little bit of problem. What if I have, let's say, the server in networking 3, and the server here, for example, is the HD Hosting Dynamic Configuration Protocol, Dynamic DHCP. What if the server that's supposed to provide IP address to all these devices is in network 3, for example? Well, if that's the case, we can configure the router to allow that type of traffic to be passed to the switch, to the server, sorry. So here we go. This is the point of subnetting. So we can get rid or can solve the problem of broadcast domain, which basically means when you have a lot of computers within one network, producing broadcast messages will lead to consuming of the bandwidth, consuming of the resources of the machines. How do I do that? How do I fix that problem? Break down your big networks into small networks and let them all be connected with routers instead of switches. So this is a very, very simple explanation of why do we need to do subnetting. Now, of course, we have subnetting for IPv4, we have subnetting for IPv6. In this example, we're going to be talking about subnetting for IPv4. So the question here is, I have this IP address, and I want you to break it down into 5 networks. So let me just come here and put the question in this area here. And here we go. So the idea here that I need to break down this IP address of 192.168.100 into 5 networks. And I have the prefix which is 25. Prefix 25 simply mean my subnet mask is 250. Wait a minute. Let me just increase the thickness. So the subnet mask is going to be 255.255.255.128. That's the subnet mask here. Again, we talked about how do you convert a prefix into a subnet mask. Now, since this is my subnet mask, and since this is my IP address is 192.168.100.0, and remember here, the prefix here is 25, I can tell all the networks that I'm going to be dealing with will have no problem with this term and this term and this term, and all the work will be done in this term here. So since I have 128 here, basically this is a case where I have to go and work binary. So I'm going to take this section here and I'm going to put it in binary. So in binary, this 128 is basically 1 and then 7 zeros. And the 0 is basically 0, 0, 0, 0, 0, 0, 0, 0. Now, since I need to create 5 networks, I have to, and again here, just in case you didn't know, there will be the line that's going to break down my IP address into the network portion and the host portion. So whatever you have to the left is for the network, and whatever you have to the right is for the host. Now, since I'm trying to break down my big network to 5 networks, you have to ask yourself this question. How many bits do I have to borrow from the host portion to be able to create 5 networks? And what do? You have an equation for that. We said 2 to the power of that number that we're talking about should be always greater or equal the number of networks that I need, which is 5 in this case. So we start with borrowing 1 bit. And the bit that we're going to borrow is this one. So if I borrow 1 bit, I will end up having 2 to the power of 1, which is 2, and 2 is not greater than or equal to 5. So 1 is not enough. Then I'm going to do and borrow 2. 2 to the power of 2 is 4. 4 is not greater than or equal to 5, so that's not enough. So you're going to go and borrow a third one. Now 2 to the power of 3 is 8. 8 is greater than 5, so yes, I need to borrow 3 bits. Since I know that I'm going to be borrowing 3 bits, after that I will have a new line that will break down my network portion from the host portion. Now, this part here is basically my host portion, and those 3 bits are going to be added to the network portion. Now, since I am borrowing 3 bits, that basically means I can have as much as 8 different networks. I don't care about 8 different networks. I just need 5 of them. So I need to list all these 5s. Now, remember here, I'm borrowing those 3 bits. So all my work is going to be done with those 3 bits. But this one is going to still be there, and those going to still be there. But I'm going to be playing with those 3 bits. So all the possibilities that I can have, and let me just state them here. It's going to be 0. Let me use a different color. So I will have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and then 1, 0, 0. Now, of course, I can continue with the other networks, but I just need 5, so I'm going to stick with those. So I need to come here, and let's start typing those networks in this area here. So let me just use the mouse now, and let me increase the font size, and let's get this party started. So the first network is going to be 192.168.100 dot. You know what? That didn't work. 14 is not big enough. 6. Okay. So here we go. So this is my first 3 part of that IP address. Now, my job is basically to ask myself, as I said before, I'm going to choose the first 3 zeros here for my first network. So those 3 zeros, which basically they're still here, 3 zeros. So I'm going to end up having a 0 here with the prefix. Now, since I'm borrowing 3, and I originally had my prefix as 25, so now it's going to be 28. So that's my first network. My second network, and let me just state that. So here, this is my first network. My second network is going to be this one. So those 3 bits are going to be replacing those 3 zeros here. So it's going to be 0 here, 0 here, and 1 here. So I need to come here and write that IP address. So I'm going to have 192.168. dot 100 dot. Now remember here, I'm replacing that 000 with 001, and that basically will make it 16 backslash 28. Now the third one I am going to use is basically this one. I think that's not 30. No, I made a mistake. This is 32. Wait, no, it's 16, sorry. Because here, this is 0001, so it is 16. Now the third one I'm going to use, basically, I'm going to replace this 0 here with a 1. Let me just write it down here so I don't make any mistakes. And that will make it 32. So let's go ahead and write that down here. 192, 168, 100, and then 32, and still have 28 as a prefix. Now my fourth network IP address is going to be this one, which basically means I'm going to replace this with a 1. And in this case, this will be basically 48. Okay. Now, if you're just wondering where am I coming with those numbers, let me just explain this. If you look at this IP address and you convert it to binary, to decimal, this is going to be 48. Use a calculator and you should get 48. So let's go back here. I'm going to have 192, 168, 100, and then 48 backslash and 28. And then the last one that I'm going to have is going to be, let me erase those. Here you go. Get out, get out, get out, get out. Now we'll have 0 here, now 0 here, and I need to erase this 0 because this is the last one in the list that I have down there, and this is going to be 1, and that is 64. So let's go ahead and do that here and put it as 64. 192, 168, 164, and then we put 28 here. So these are my 5 networks. Each one of those networks, let's just go ahead and talk about that. Each one of those networks, let me just let me take out all this calculation here. I'm going to go and take one of those as an example here just to show you how to extract information about each one of them. So let me take this one in the middle, for example. I want to know what is, again, the subnet mask. I know what is the IP address, what is the first available IP address, what is the last available IP address, what is the broadcast, and what is the number of hosts. So what is the subnet mask here? Let me just erase this so you don't get confused by it. And let's go sub. Now, before I do anything, I can, if you list the values as you can see here in this table, I can immediately come here and tell you the first available IP address is going to be 1. The last available IP address is going to be, let's see, the broadcast is going to be 15. The last is going to be 14. And the number of devices I'm going to have 14. Because if you subtract from 1 to 14, that's 14 different devices. And if the first available IP address, you just add 1 to the 0, so it's going to tell you. The broadcast is going to be whatever the IP address of the next network minus 1, so it's going to give you 15. So if I have my addresses listed, as you can see here, extracting the information is going to be easy to do. But again, I am not looking to do that this way. What I'm going to be doing, I'm just going to start with sub. I'm just going to start with the IP address itself. So this is the prefix 255.255.255. Again, since this is 8, that basically means I have 4 1s and 4 zeros. And I am lazy a little bit, so let's just go ahead and use a calculator. And I'm going to have to go here and put it as scientific, no, programmer. So if I go binary, 1 1 1 1, and then 4 zeros, and here it is, it's 240. So that will make it 240. 240. Now this is subnet mask. What you need to understand that all these devices will share the same subnet mask. Okay. Now the first available IP address, whatever the IP address that you have here, you're going to have to add 1 to it. So it's going to be 192.168.100.34 or 33, sorry. Now for the last, I'm going to leave the last. I'm going to go straight to the broadcast. Or before I get to the broadcast, let's do the number of hosts. Since I have 4 bits, remember here, when we draw the new line, we had 3 zeros here, and then we had originally 1 0 here. So all these 4 bits are going to be taken away. Sorry, those 3 bits are going to be taken away and added to the network portion. So the network portion which was 25, we added 3 to it, so we get 28. The bottom line here, I will be left with 4 different devices, 4 different bits here. And because of that, the number of devices I can have in each host is 2 to the power of 4 minus 2. And that is 16 minus 2, and that's 14. So in every one of those networks, I can have 14 different devices. Now let's go ahead and talk about the broadcast. The broadcast basically means you're going to have to flip those zeros to 1 to be able to find out what is the broadcast. So let's look at the original IP address. The original IP address is 32. And 32 basically means you got 0, 0, 1, 0, and then 4 zeros here. Now remember here, this is the line that separates the network portion from the host portion. And I'm talking about here 32, this value here. So to get the broadcast, I have to flip all these zeros to 1. And as a result, this is going to be, again, if you use a calculator, it's going to be 32 plus, let's see here, this is 10, and this is 15. So you put this and this, you get 7 here, you get 4 here, so it's 47. The last one is going to be, again, 192, 168, 100, and then 47. Now, if you look here, I got 48, so just subtract 1 from it, you get the broadcast here. Now, the last available IP address is going to be 192.168.100.46. Again, whatever the broadcast, you subtract 1 from it. And if you count the number of hosts you can have between 33 and 46, you will get 14 different devices. And this will be the end of the first case. Let me save my work. I'm going to cut this portion. And I'm going to create a new file. So paint. And I'm going to extend the view here. So let's resize it. Pixel, I'll put here 4,000, huge. And I'll put the solution for this part here. So I'm done with this. Let's keep it on the side. Let's get back here, create a new file. And let's see the second case. Now the second case, let me copy it. Well, let me copy the whole thing because I'm going to need the IP address. Let's go ahead and put it here. And I can take all this away. I just want to keep case 2 and the IP address. So we'll go back here. What do we have here? Now, in this case, we're doing the opposite. I'm telling you that I need to have a number of networks, which I don't know how many exactly, but I'm telling you each network should have 12 hosts. So what we're going to be doing in this case, we're going to follow the same steps that we started with in the previous case. So I'm going to have 192.168.100, no change going to be applied. I'm going to be only concerned with the part of the 0. So it's going to be 0, 0, 0, 0, 0, 0, 0, and we're missing, okay, this is a 0. For the prefix is going to be, again, since they're all, this is going to be 1, this is going to be 0, 0, 0, 0, 0, 0. Now this one is coming from the fact that this is 25. And this is here 255, 255, 255. You flip them all to binary, you're going to get 8 ones, 8 ones, and 8 ones, and then that's all 24, and then you add 1 to it, so you get the 25 here. So this is, again, my line here that separates the network portion from the host portion. Now, what we need to do in this case is to ask ourselves a different type of question. Previously, I asked how many bits do I have to borrow to get 5 networks. Now I'm going to have to ask myself, how many bits do I have to keep to get 12 hosts? And in this case, we're going to start from the right. And we're going to use this equation. 2 to the power of that number minus 2 should be greater or equal 12. Now, why am I subtracting 2? Because we said there's 2 IP addresses reserved for the network and for the broadcast. You cannot use them. So you need to exclude them from your calculation. So when I say 12, originally I need to have 14, not 12. Because 2 of them, you cannot touch them. Anyway, so let's go ahead. We're going to ask ourselves this question. If 1 is enough, no, 1 is not enough, because that's going to be 1 to the power of 2, which is 2. 2 minus 2 is 0. And then you get to this part. What do we have here? We have 2 bits. 2 to the power of 2 is 4. 4 minus 2 is 2. Not enough. Let's see 3. 2 to the power of 3 is 8. 8 minus 2 is 6. That's not enough. Let's go ahead and add another one, which is 4. 4 to the power of 2. What is that? 4 to the power of 2 is 16. 16 minus 2 is 14. And that is enough. So my new line is going to be this one. And this is just a coincidence that I was left with the same number of bits to borrow and put it here. So what is this telling me? This is telling me that the answer for this question is going to be identical to this question. But I just looked at it in a different way. Now, the difference between them, here I was only concerned with the first 5 networks. But here, in this case, I actually going to have 8 networks. So I can just go ahead to simplify it. Let me go back here, copy that, and let me come here and put it here. Now let me just take this part away, delete that, and delete that. What you need to know here is that you will still have 3 more networks to go, okay, in this area here. And those 3 networks, so I can actually just come here and figure that out. So the last one we used was 64, and I'm looking at this portion here. 64 was 0, 1, 0, 0. And remember, this is my line, this is my second line, and all of these are zeros. Now the other options I can have, and I'm just going to list them here with a different color. I can have 1, 0, 1. And then I can have 1, 1, 0, and then I can have 1, 1, 1. So those are my 3 additional networks that I have to add here to make it work. So I can come here and do that. So this is going to be 192. Oops. Let's change the color to black. Increase the font size. 192. 168, 100, and this number here is, let me do the calculation really fast. This here is 64. You know what? I am having one of those moments. I don't want to do a simple math. So let's go ahead and hit our basic standard. So 64 plus 16, that's 80. And yeah, if you add 16 to this one, you get 80. So let's go ahead and do that. 80, 28. Let me extend the view. The second one, 192, 168, 100. Is it 168 or 186? I don't know. I'll just check later. Now, in this part is going to be, let's see here. I believe 96, because that is 64 plus 32, and here it is, 96, and that would be 27, and finally 192, 168, 100, and the last one is going to be 127, I believe. Oh, this is 28. This is going to be 28 as well. Let me just make sure I got it right. Let's go back here. Go to the programmer. We have 1, 1, 1, and then we have 4 zeros. Oh, let me just 1, 1, 1. Well, wait, I didn't click on binary. My bad. 1, 1, 1, and then 4 zeros. Oh, how? Yeah, yep. Sorry, I forgot. It's 112. It's not 127. 112. And those are the extra IP addresses. Now, of course, just like how we did the first, the last, number of hosts, broadcasts, it's the same story here. So let me just cut this from here, put it here. Let me clean. Nope, cancel. I'm going to try to clean my screen as much as possible. And let me cut this part. And I'm going to go to here and put it. Let me put it next to it. Okay, so now before I move to case 3, we need to understand something here really important. Whether it's case 1 or case 2, every single network will end up having 14, being able to host 14 different devices. So each one of those networks, you can have up to 14 different computers and network and devices connected to those networks. Now the question is, sometimes in networking, when you have two routers connected together, this connection by itself, it's considered as a network. And you will need an IP address here and an IP address here. So for example, if you chose to use this IP address for this network, out of those 14, you'll be only using one here and one here. And then you will have 12. Those 12 will be wasted. You cannot use them anywhere. Well, you can use, let's say, for example, here for a VLAN and here for a VLAN. And there's something called look back and lookup, and we have a lookup here that we can use some IP addresses for them. But maximum, it's just two ends that's trying to get connected. How many out of those 14 you want to use? Maximum 4. Either way, no matter how many IP addresses you're going to be using here, you will be wasting some IP addresses. And one of the biggest problems that we have with IP address version 4 is the limitations of IP addresses. So not only that you have limitations and now you're wasting them, so that's the problem that we have with those two cases that we are talking about. So to solve this problem, we have a third scenario case, which is kind of very similar to what we had in case number 2, but we're just going to have to apply a little bit of modification to it, and we'll see how is that going to work. So let me just delete those lines, and let's go back to my original page. And let's go ahead and talk about that third case here. So I am going to copy all of this. Let's put it here. Let's extend the view, take all this out, and let's keep case 3. Now in case 3, what do I have? I have the same IP address, but this time I'm telling you that I am supposed to have 60 different devices for network 1, 5 devices for network 2, and 2 devices for network 3. So how do I handle the situation? Okay, we'll start with the case number 60. We take each case individually, each network individually. So case number 1. So for network number 1, which contains 16 different devices, this is what we're going to be doing. We will have, we will start the same way we started with the case number 2. And we will look at, since this is 25, nothing's going to be done to the first 3 numbers here. We're going to be focusing on the last one. And the last one, as we showed you before, is going to be 0, 0, 0, 0, 0, 0, 0. This is 0. And for the subnet mask, we say we're going to have 1, and then 0, 0, 0, 0, 0, 0, 0. Now, as you know, we have the same line that we used before to separate the network portion from the host portion. And this is the network portion, and this is the host portion. Now, the question that we have to ask ourselves, we need to have 60 devices. So question is, how many of those bits of the host that I need to keep to be able to get 60 devices? Remember here, the equation is 2 to the power of that number minus 2 should be greater or equal 60. Now, if I go 1 is not enough, 2 is not enough, 3 is not enough, 4 is not enough, 5 is not enough because 2 to the power of 5 is 30, so that's 30. Let's go here and look at 5, 6. 2 to the power of 6, I think that's 64. 64 minus 2, that's 60. Let me just make sure that I am not doing any mistakes with my calculations. So 2 to the power of 6 minus 2, that's 62. So yes, I basically need to keep 6 bits to be able to get 16 different devices. So let's go ahead and do the calculation here. 1, 2, 3, 4, 5, 6. Those are my 6 bits. And that basically means I'm going to have to draw a new line. And that new line is going to be here. So based on all of that, I have 1 bit that I need to borrow to be able to create a network that will provide me with 60 different devices. Now, since this is the case, I have a 1 bit here. This bit could be 0 or could be 1. I'm going to choose the first one, which is 0, for the network that I am going to have, network 1. And for that reason, I'm just going to come here and say network 1 is going to equal 192, 168, 100 dot. Since I'm using 0, so everything here will be 0, so we'll keep it as 0. And you put a backslash. Now, previously it was 25, and now I'm borrowing 1 to it, so it's going to be 26. And that's networking 1. Now, again, from that point, you should be able to calculate all the other calculations. Now, for network 2, which basically require 5, what I'm going to be doing, as I said before, is that I need to temporarily, I'm going to assume that I am going to be using the second available IP address, which is network 1. Which is this one here. So I replace this 0 here with a 1. Now, if I go ahead and do that, 192, 168, 100 dot. Now, since this is going to be 1, so that's going to make it 64, and this is going to be 26. Now, the question that you need to ask yourself here, I need only 5 devices, but this network by itself is going to give me 62 different devices. Like, I can have 62 different devices in this network, where in reality, all I need is 5. So I am wasting way too much IP addresses. To solve this problem, what we like to do, we like to look at the problem as a new one. So first of all, let me just come here and type N1 is going to be 192, 168, 100.0 backslash 26. Let me increase the font size here to be 18. And I'm done with that part. Now what I'm going to do, let me erase some of the information so I don't need this anymore. Oh, this is going to take forever. Remember here, I'm done with all this. I had to go through this measure because I want to take this part away. I don't want to take the other one underneath it. So I'm going to have to take this all away manually. Okay, so let's go ahead and delete this section here. I don't need this anymore. And let's go back here. So this is, again, my new case. My new case is that I have this network IP address and I need to get 5 different devices. So what we're going to do, we're going to start from this point here, and we're going to come here and say, well, I have my IP address, which is going to be 010000000. That's the 64. And then I will have my subnet mask, which is going to be 26. So we got 11000000. Now my line is going to be this one here. And the question that you're going to have to ask yourself now, how many bits, remember this is the host portion, this is the network portion, how many bits of those do I have to keep so I can have 5 devices? And the answer for that will be 3, because 2 to the power of 3 minus 2, 2 to the power of 3 is 8, 8 minus 2 is 6, and he wants me to have 5, so I can actually use 3 here. So based on that, I am going to keep those 3. I'm going to keep those 3, and I am going to gonna borrow those 3. So 3 of those are going to go and be added to the network portion, and I'm going to be keeping those 3 bits here. So with that being said, because I'm borrowing 3 bits, I basically can have 8 different networks. I can have 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on. Now, since I only need one at this point, I'm going to use this one here. And then what I'm going to do after that, I'm going to use this one for the next network. So I just need those to keep those two. One of them is going to be used for network 2, and one of them is going to be used for network 3. So I don't need the rest of the networks. I can come here and take this out. And I know that I have to keep those two. So let's start with the first one for network 2. Since I'm going to go with all 0, so this and this and this is going to be kept 0, I'm going to get the same IP address, which is going to be 64, because no change is going to be applied to any of those. But the issue here, this is not going to be 26 anymore. This is going to be changed. It was 26, and I'm adding 3 to it, so it's going to be 29. So the next the next network IP address is basically going to be 192.168.164, but the prefix in this case is going to be 29. So let's go ahead and write that down here. And let's go ahead, network 2 equal 192.168.164. This is going to be 29. And let me just move it a little bit. And now I'm done with network 2. Now, what I'm going to do after that, I'm going to come here and create another network IP address. I'm going to call it NT3, temporary for network 3. This is not going to be used as for network 3. And in this case, I'm changing this 0 to be 1. That's because I'm using this one. Remember, those 3 bits represent those 3 bits, and I'm changing this 0 here to be 1. The IP address in this case is going to be 192.168.100 dot. Now this here is basically 64 plus 8. So that will make it 12, 7. So 72. And remember, it's 29. So this is going to be the IP address. Now what I need to do after that is basically to get rid of all this. Okay, let's just take this out, take this out, take this out. Okay, so let's go back here and see what can we do. Now, in this case, we want to have 2 networks. So we're going to start with this IP address. And from this IP address, we're going to have to figure out how do we get 2 networks. So we'll start here again. We said nothing's going to be applied to those. No change. All the work is going to be with the 72. So we're going to immediately go and put it in binary. So I'm going to have 0, 1, 0, 0, 1, 0, 0, 0. I remember that from the previous example. Again, if you change 72 to binary, you should get this one. Now, the subnet mask is 29. Sorry, that's 29, not 26. Because we're using 29 here. So 29 is basically 24, 25, 26, 27, 28, 29. So this rest are going to be zeros. Now my line is basically going to be this one. And I have to ask myself the same question again. How many bits of those 3 I need to keep to be able to get 2 devices? And the answer will be 2, because 2 to the power of 2 minus 2 should be greater or equal to 2 to the power of 2 is 4. 4 minus 2 is 2. So that will make this condition true. I need to keep those 2. And because of that, I have 1 bit left here that I can actually borrow and add it here. Since that's the case, I have 1 bit here. I can further subnet this into 2 networks. The first one is going to be 0. The second one is going to be 1. I really don't care about the 1. All I care about is the 0. So for the 0 case here, I am going to use this network IP address because, again, 0, that basically means this is going to be 0. And if you convert this back to binary, to decimal, you get 27. But remember here, you're borrowing 1 bit from this portion, from the host portion to the network portion. So instead of 29, it's going to be 30. So the third network IP address is going to be 192.168.100, and then 72, but this is going to be 30. I always get confused between numbers. Now my brain is telling me, is this 168 or 186? I need to go and double check. So let's go ahead and type that. My third network here is going to be network 3, 192, 168, 100, and then 72 /30, and that will be it. This here is the third case scenario. Let me cut that. And let me go to my original. I'm going to put this here. Let me try to do some cleanup. I'm going to send this picture to you guys. And just remember here, in a lot of situations while I was answering this question, I got to a point where I have multiple networks to choose from. So because that option is available to everyone, so whatever network that I chose, you may decide to choose something different. So that will tell you that we are not necessarily getting the exact same answers, I would say. But here's one thing you should know. If you actually miscalculate any of these things that we just did today, and you try to apply that miscalculated IP address into your packet tracers, your packet tracer is going to just throw it back to you. It would not accept it. So I hope this one was helpful. I'm going to provide you with a little bit more files and more examples later. So until that time comes, you guys enjoy the rest of your day.